Hi, guys. I'm getting signals. Okay. Let's see what we have here.
Would I also have to?
All right, before we get everything into full swing, did anybody have any specific questions about any material from exam 3? Anything at all?
I might take it depending on if I have to take English in the fall. If I do have to take English in the fall, I might do it like the spring semester.
So I don't have any questions in chat. So today's session will mostly be about quiz for the next quiz, and that is mainly epidemiology and the tail end of virology. So let me first pull up some epidemiology.
I thought I was doing a lot worse.
In the meantime, I want to share my screen real quick. Now, I know you guys probably don't really care about the elections too much, but if you do have the time, it takes 2 seconds to fill out this ballot. Most of these offices, for at least the students, there's only like one person that is like nominated for it. So if you want, you can vote for them. I think there's only one student office that has 2 people, so it's pretty fair. You can flip a coin for that one. But what matters is at the end, your professor got nominated as one of the top 10 professors. So if you want to vote for her, that's great, unless you have a bias towards another one. Good, Hannah. If you do have the chance to nominate her or vote for her, I'm not sure when these close, but it should like pop up like on top of your canvas if and it's like I think the message says it only takes like 30 seconds to do. So you guys are fine. If you want to read about the candidates, sure, but we're counting on that last part. So I'm encouraging everybody to vote. But let me go ahead and pull up. Let's do first epidemiology, and then we'll do virology, because epidemiology, in my opinion, is a little bit easier. Let's see. Virology, it's a little bit more complicated in that there's a lot of layers. So let's do that. Also, make sure that you turn in all of your things due today. And I would highly recommend getting started on like the easier parts of all the other labs that we started. So like the definitions and like the first questions that you have to fill out for your senior picnic, try to get all that done now. And then when you go to interpret your results on Wednesday or Thursday, then you could fill out that section and do the small write-up, and that's it. Like you do the first half and you finish that before you come to lab again. And then when you come to lab, you finish it and let your spring break be clear. Like if you want to work on your the micro project, you can. If you want to work on your unknown project, you can. But I don't have all those extraneous things go to the wayside. Like check them off, and then work on the others little by little. Like you guys have the luxury of having spring break. Like I did not. We had, week of instruction, and then after that week, it was, micro project, unknown project due. So make sure that maybe by the end of this week too, you have maybe dedicate at least, an hour. It doesn't have to be all in one sitting, but an hour to that unknown project, just writing out like, my patient is severely immunocompromised and now she has an infection. She knows that this is the end of her life, or she is alone and she doesn't have anybody to help her through this. And just, similar things like that, and evaluate the mental health of the patient. If you do those things and write those things up, then when you have your etological cause, then you can go back and do more things. Embed all those pictures. It's really easy to do. You just select all the ones that you took in one day and put them in. And then, if that's all you can do for that little bit, take a break, because it is pretty daunting. Take it section by section. So like first you're going to be like, okay, I'm going to do day 1 tests, day 2 tests. I'm going to do all the tests first, and then I'll go into more, and then I'll research what to how to treat this, the prevalence, right? Going into those smaller details later on will help. I can't say that I can read your guys's unknown projects, because if I say that I could proofread them and I could tell you if you're on the right track, and you send me these 20-page result reports, it's going to be hard. So if you have a specific question about your unknown report, I can answer it. But if you're just like, can you look through this? I can't. So if you're like, did I have enough detail in this spot? I can read that spot and say, yes, good job. Or maybe try to include something here. So that I can do, because if I had a 20-page report and it's a lot of fluffy language and not a whole lot of statistics, and I'm like, you need a statistic here, you need a statistic here, it's going to drive me insane. And for how God knows how many people that would take advantage of that, opportunity, I would not sleep for a week. So that is the that is the boundary. So let's get into the epidemiology, right? So the biggest part of this chapter is the definitions. So you want to know pathology, etiology, you know what I mean, this word right here. I'm only human, I can't pronounce everything. So this right here, know the differences between infection and disease. All of these are pretty, simple. I feel like we've gone a lot over it. Trying to see, you guys know about this. That page where it says like normal microflora of the mouth, the skin, the anus, the vagina, all of those things. Overlook that, and like not overlook it, but go through that. And make sure that you can, like say like, okay, yeah, like on my skin, I have probably some kind of staph species, like staph epidermidis. I can have any transient bacteria I pick up, right? Or I could just have Staph aureus in my mouth, right? What bacteria is in your mouth, and understand, like the different normal flora, and then how you get that normal flora. But I think we went over that pretty well. Let's see. Signs and symptoms. This is going to be number 1, especially if you go into healthcare. What is a sign versus what is a symptom? A sign, I always like to think of a stop sign. It's something that I can see and it tells me what to do or what's happening, right? I need to stop because this is an intersection, right? But a symptom is, think of sympathy, right? It's a feeling. So a symptom can only be felt by the patient, while a sign can be seen, you can visualize it. So a sign would be fever. If you do a CBC on the patient, you can see the different numbers of white blood cells, red blood cells, right? If you do that, then you can compare it to what's normal, and that's a sign. Sometimes signs have symptoms. So like if you have a fever, you could feel weak, you could feel ill. You know, you just don't feel good when you have a fever. You typically feel very sluggish. If you have distended bowels, right? Or like you have bloating that can be seen and it's very visual. You might have abdominal pain, right? That's something that's a symptom versus a sign. So be careful when you hear, you know, the patient has abdominal swelling and abdominal pain. What is the sign? Make sure that you can say, okay, what's visual? A syndrome, it's just a group of those. I feel like that's pretty straightforward. No incidence versus prevalence, right? So let's see. So incidence is like when you think of like an incident happening, you know, it's how many new times, right? It's very much in the present. You know, if you say like, oh, there's an incident outside of the classroom, right? That is it's a new event happening, and it is changing, you know, how we view said incidents in the past. So prevalence is just, you know, how many incidents have happened in general. So like if somebody says, well, that's the third one that's happened outside of the class, then that would be the prevalence, right? So think of singular versus many, or new versus new and old for that one. So like the incidence for COVID, this is the best example. I know it's worn out, but the incidence for COVID would be the daily new cases, right? But the prevalence would be how many in the past did we have. It could be the past week, it could be the past month, year, right? But yes. So generally, incidence is a lot lower than prevalence, right? Because, you know, I don't want to get math involved, but if we look at incidence versus prevalence, right? We said that incidence is new, right? Okay, so incidence is new, prevalence is new plus old, okay? So it would make sense that if these are equal, that this is going to be greater in general. Like this one is going to be more if we're adding more. Like I don't know why, but it always trips people up. And I cannot tell you how many times, even in my normal class, I've had to explain it over and over. Like, I think it just, people get stressed during an exam, they forget it. But this is just the, you know, visualization for you. It's no longer words, it's a visualization for you guys to remember this. Okay, so that's pretty good. And then morbidity versus mortality. Okay, so mortality, right? Mortality, when you think of it, is death, right? Please think about it like that. The French word for death is, this pen is dying. The French word for death is mort. Mort is the French word for death. So if you're thinking, what is the death rate of a disease, right? You want to think mortality. While morbidity is spelled very differently, and it's just the number of people affected. Okay, got my hair caught in this pen, but anyways, so that's one of the key differences between morbidity and mortality. So if all else fails, just remember, if you're having trouble differentiating between the two, mort is death. That is the word for death. Okay. Let's move on. So I feel like these are pretty good. So communicable and contagious, they are two different things, but they are very similar. So the one thing that you want to point out between these two definitions is contagious is easily spread from somebody else. Is easily spread from one to another. While communicable, it might be a little bit hard. So for this one, you can see obviously that chickenpox and measles fit in both. So, you know, not all contagious or not all communicable diseases are contagious, but most likely all contagious diseases are communicable. Okay. So that's kind of the thing. You see what that is? You guys good on some of these definitions? I don't want to spend all of these all the time on this, but these are really important too. So sporadic. I want to draw a really bad map of the US. So don't judge me too hard. So if we're looking at the US, we got like Michigan here, and Maine, and Florida, and like Texas, Texas, and then like this. It's not terrible. But if we have like a picture of the US, right? A sporadic disease is going to look like this. You know, somebody in LA gets it, somebody in New York gets it, God, somebody from somewhere in the middle gets it, maybe Florida, Washington, and Texas. That seems pretty, you know, there's not a whole lot of rhyme or reason to where this goes, and it just pops up randomly. Like you cannot predict where it could go next. Let's say somebody in Los Angeles got it first, and then somebody in New York got it second, right? It's like, how did that even happen? So that is kind of just what sporadic is. It's going to be all over the place. There's not going to be a rhyme or reason, and it's not going to look like you could visually see spread. Okay, so let me erase these little points. Okay. So now let's say we are in Bakersfield, right? We're somewhere in there. So we're in Bakersfield. An endemic disease of ours is valley fever. Valley fever is endemic to our area. So the entire San Joaquin Valley is going to have lots of cases, right? It is local to an area. We have so much valley fever. It is endemic. And it's constant. If this was, let's say this was 2017, and we move over, and then I'm just going to draw the coast. This is 2020. It's always going to be there. There's always going to be a ton of cases, no matter what you do. It is endemic. Okay. So now that we have endemic, right? Think valley fever, right? Now that we know what endemic is, let's look at epidemic, right? So this is why we have a whole flu season, right? So this is usually very quick, very short-lived, and it goes away usually. Like, you know, nobody really in the summer gets the flu, right? It's mostly in the wintertime when, you know, people are a little bit more susceptible. So it's short-lived. You know, the flu could be localized to here and here. But if we were to look at it on a map, this is 2017, it could look completely different on this map. There you could have a local here and a local here. And in those two places, you know, they may or may not have them, but when you think of an epidemic, think of flu, the flu. Um, like that's the main thing, is that it's short and it's in a given area. It's local. So if you were to see like between endemic and epidemic, first of all, it's the time frame. And because endemic is constantly there. Epidemic, it's there every so often. And it might be different every time. But pandemic, obviously we're living through one, but that is going to be like, this is Mexico. That was terrible. I know that there's the Gulf of Mexico. Don't come at me for my geography. But if this is Mexico, we see it here, we see it here, right? And with this one, it is kind of easier to track it. So let's say, somebody got one here and then somebody got one here. So let's say they took a little plane, right? They took a plane here and then off of here, they went on a cruise and it stopped, here and here. So that is the pandemic sense, is that it's not local to just the US. Mexico could have it. Hell, South America. I think that's how it's. Chile's like right here, and this is Brazil, kind of. So I'm not terrible at geography. I'm just terrible at drawing it. Then we have some here, here, right? It's everywhere. We have the sporadic outbursts worldwide. Worldwide is the given. Because if you were given this on the quiz question, the difference between epidemic and pandemic could very well be. So this is epidemic. This is pandemic. See how it's like they look very similar? There's just one little difference. This for sure is going to be on the quiz. I'm telling you now. I got so mad because last semester the the different states were shaded differently. So like this was white and then this was like gray. And then there was like something here and something here. And I was like, what does it mean? So I got confused and I just didn't, I guess I answered it wrong, but I'm still fighting for the fact that I was right, even though I don't remember what it was. So I digress. So this is going to be on the quiz. Like, I trust me on it. You're gonna have like you're gonna have like a graph A, B, C, D, and it's gonna ask, depending on your version, is this an epidemic? Is this endemic? Is this a sporadic disease? And you're gonna have to match the you're gonna have to match the disease graph or the disease map with the word. So yes, let's see what else we got here. Yeah, I just basically went through this. Yeah. So definitely take a look at these charts. It's always there, right? It's always there here, but if we go here, this is an epidemic when there's a giant spike, because there more than likely will be a graph like this. So an epidemic can be from an endemic, right? So for a while, we could have considered the normal COVID to be endemic at a certain point. But then when the Delta variant came in, that became an epidemic in certain areas, right? It wasn't everywhere, but that's the best kind of, because you guys don't know what St. Louis encephalitis is in the US. I'm trying to give you guys a little bit more of a relatable thing. Oh my gosh, you guys can't see the slides? Oh my God, I feel terrible. You guys are staring at the wrong thing this whole time. Who let me go for 20 minutes on the wrong thing? I just went through this whole thing. Oh my God. Okay, well, I just scrolled through this. That was a gnat I just got. Anyways, this is with prevalence and incidence, morbidity versus mortality. I guess it really looked like I knew what I was talking about. I was just reading the slides. Sorry. Okay. Moving on. This is a pretty good thing to know. So when we were fighting for everybody to get vaccinated all at once, it was really important because if we all got vaccinated at once, then we would have had herd immunity at a certain point. And if we had herd immunity, we could have ended the pandemic a while ago. But that was like if everybody got vaccinated on almost the same exact day, because our immunity or the strength of the vaccine would have been strong enough to develop this herd immunity. While, you know, I got vaccinated back in like April of last year. So, you know, at that time, yes, I was immune. But as the year went on, not like, I don't think we hit 50% until December vaccinated. So unfortunately, this is kind of where we were at and where we're going to be at until we have 90% immunity. But yeah, let's continue. Kind of understand the concept of the meningitis belt. It is, there's several things to consider. It's mainly these things right here. It's just understanding the cycle of an epidemic. This is pretty a simple concept. I mean, common source, they have a common source, right? It's like the senior picnic project, right? Where all propagated epidemic would be something like COVID. I feel like that's very simple to understand. Know this very well, very well. I feel like you guys should know, or at least it's relatively easy to understand the difference between acute, chronic, subacute, and latent. Because I mean, you know, think acute, little, chronic, always, right? If you have a chronic disease yourself, it's going to be forever. Subacute, right? It's like in the middle. It's under acute, but above chronic. And latent is the latency in the symptom onset. So I'm gonna move on from that one. Local, systemic, pretty straightforward. Focal, just remember that's the in between. It's from a local to a systemic. So it could be like, you know, we get a skin infection, right? You have an open cut on your arm. It develops a local infection. It's only on that cut, but all of a sudden the bacteria enters the bloodstream, and now that becomes a focal infection, and then eventually a systemic infection. So yes, okay. Septicemia is the same as sepsis, right? It's just bacteria in the blood, or I'm sorry, growth. The specific word is growth of bacteria in the blood. This is going to be on the either exam for sure or the quiz. So growth in the blood is septicemia. That is actively replicating. Bacteremia is just bacteria in the blood. It may or may not be replicating. Toxemia is toxins in the blood. Viremia is viruses in the blood. I think you guys get the picture of those definitions. This chapter is a lot of definitions. Primary, secondary, and subclinical. I want to say also a little, they're kind of in the middle. So a primary infection is that initial infection that causes an illness. So, you know, it's the redness at a site, right? It is some kind of colonization, right? And once you get that infection, your immune system is lowered, and now you have a secondary infection because the bacteria that wanted in is now getting that door open. So once you have that door open, then another one can come in. So like, for example, hate to tie this back, but some people who had the primary infection of COVID got pneumonia, right, as a secondary infection. That could have been either because of the excess fluid or just being exposed to it that developed that secondary infection, or some of them were put onto ventilators, right? And that could have led to a subclinical disease. I'm sorry, that could have led to the secondary infection, right? So that's just, you know, it's opportunistic, is that secondary infection. Subclinical ones are ones that just you don't really see coming. So like, they like, think of the word subclinical as they like fly under the radar, like they're under the clinical nose, right? They're there, but you can't see them. Let's see. Okay, this, understand this. Draw this, do something with this. So this is very important in terms of knowing when things happen. So let's say you get infected with something, right? Everybody's going to experience an incubation period. We don't know we have it, but we've been exposed, right? The prodromal phase is where you start getting like kind of symptoms, like you feel off, like your nose might run a little bit more, your throat is scratchy, you need to clear your voice sometimes. It's not normal. Then you have your invasive phase where you feel like crap all the time. You know, you have the full-blown symptoms of whatever infection you have. And usually what happens is that you die. You either die at this point, like at the peak of the invasive phase called acme. So you either die at acme or you experience the decline phase, where you experience these signs and symptoms start to go away. They return back to like manageable symptoms at manageable levels. And then your convalescence period is like, you know, you're just recovering, you're fine, right? But the two things you need to understand are the severity of the symptoms as you go. When death would happen, it's either going to be in this invasive phase or at the acme, at or before. And then when secondary infections happen, which is in this decline phase, because your immune system is still trying to fight it off, and so it's at a disadvantage. And so the bacteria come marching in and give you a secondary infection, and then it starts all over again. And good luck clearing that. Okay. This goes a little bit back to your one of your labs. It should be on the back, like reservoirs versus modes. So definitely review that one. Look at that chart, and then you guys will learn a little bit more about Typhoid Mary, but she is a human reservoir. She is a carrier. Let's see. I think just under, like, if you go to your review page and you fill this out and you gave examples, it will give you a pretty good idea. Like, I think it outlines all of this. It gives you a pretty good idea of what these should be. Isolation versus quarantine. No, those two different definitions. They are different, although they are used interchangeably in the current day and age, right? God, I hate talking about COVID so much, but I swear to you, it is the most relatable thing to say, because I mean, we've all experienced it. But yes, so these two slides of definitions, vector control, it's like if you were to say like mosquitoes and the Zika virus, right? If you were to wipe out and vector control all of the mosquitoes, then you would have severely less rates of Zika. That's basically, yeah, that's part of the bed nets, is that you put that barrier there, you're not going to get bitten during the night when they're most out and about. But quarantine, separation of healthy people, and then isolation is the separating of infected people while everybody else can live normally. Okay, so I'm gonna pause it here, time out, and I'm gonna go ahead and let you guys off to a break. Be back by 5:40, and we'll continue with the second half of epidemiology, and then I'll focus a little bit more on virology. Okay, guys, so I will see you in a minute.